Welcome. So what I have in this case is 3x plus x squared plus 5x divided by x squared minus 2. And I like this problem because it kind of hits a nerve with students as they're looking and talking about adding and subtracting rational fractions. They look at this problem, they're like, OK, but what am I going to do with my LCM? Well, it takes me back to another similar problem. What if I had 5 plus 3/4? How do we add a whole number to a fraction, right? Because remember, when we're adding fractions, we know that they have to have the same denominator. But 5 doesn't have a denominator in its current format, right? So what I do is I rewrite it as a fraction. So now I have it as 5 over 1 plus 3 over 4. Now I can find the common denominator and get them to be like terms. Right? So I'm going to do the exact same thing with my rational expression. I'm going to convert this over to a fraction by putting it over 1. Now it's very simple to say, oh, well, my LCM then is between 1 and x squared minus 2. So my LCM is just going to be x squared minus 2. So therefore, to have these have the same denominator, I just simply need to multiply this side by x squared minus 2 on the top and the bottom. Now I need to make sure I apply my distributive property. So therefore, I'll have a 3x cubed minus 6x plus x squared plus 5x all over my LCM, which is x squared minus 2, or my least common denominator. Now I can combine my like terms, which I can only combine the negative 6x and the positive x. So I'm left with a 3x cubed plus x squared minus x divided by x squared minus 2. Again, how can we factor this even further? Let's factor out an x. So therefore, I'm left with a 3x squared plus x minus 1 divided by x squared minus 2. Now I need to determine what are my constraints. So remember, to find our constraints or restrictions of our problem, we need to set our denominator equal to 0. So I'll use the square root method by now isolating my x squared. Then I take the square root, take the square root. So x cannot equal plus or minus the square root of 2. Because remember, when you introduce the square root, you have to include plus or minus. So my restriction is x cannot equal plus or minus the square root of 2. So there you go, ladies and gentlemen. That is how you add rational expression when one expression is not rational yet. Thanks.